You watched a whole wizard tutorial. You followed every step. Then you opened your own model and still don't know where to start. It's not a knowledge gap. It's a methods gap, and it's fixable. This video is about how to learn something in SolidWorks. In real practice, tools need to be deployable on demand, not just recognizable from a tutorial you followed once. Whole Wizard has a defined structure. You pick the type, the standard, specification, and then placement. Without understanding that structure, every new whole situation feels like guesswork. Most tutorials walk through one example. They don't explain why each decision was made or what happens when your situation differs. For learning anything in SolidWorks, there's a roadmap you need to follow, a framework for approaching any new SolidWorks tool. And what I'm going to show you is the same process I go through when I see a new tool or have seen a new tool in the past that I didn't understand or didn't know how it works. In simple terms, you need to understand what the input is, what the settings are that you can change, the output you're going to get from those settings is, and then how your design intent can be folded in. It's a framework that you can use for approaching any new SolidWorks tool. Today I'm going to use learning the whole wizard as an example to show you the process that I go through to understand any new tool in SolidWorks. I've never properly learned the whole wizard. I've just used bits and pieces of it as I go, but now, today, we're going to learn it properly, and I'm going to show you that process. Let's jump in. All right, now, I'm going to start anywhere. I'm learning something in SolidWorks when I was first learning things 10, 15 years ago, 20 years ago even. You'd use forums, you'd use whatever search you could come across. Things are a lot smarter now, so you probably don't have to go as far or as deep. We'll just start with the simple stuff. Jump into Google, type in what you're looking for. In this case, teach me about SolidWorks Whole Wizard. This is going to pop up very quickly with some options. There's an AI overview, and let's zoom across here and zoom in. SolidWorks Whole Wizard automatically creates standard holes like counterballs, countersinks, and tapped holes without requiring you to manually draw complex cuts. It's giving you an overview, AI overview, and giving you information about how to use the whole wizard. Start the tool, define the hole, position the hole, locate the center, finish. Pretty simple framework for finding and learning about a tool. Even here, the next step, why use it? That gives you some understanding of design intent, all right? Why would you use this tool rather than something else? And that's what's really important through SolidWorks and your learning and your work as a designer or engineer. Having that design intent to smooth and speed up and be efficient in your workflow. So that's place one. Place two, where I'd go to find things. YouTube. SolidWorks Whole Wizard. And now I've got obviously a few subscriptions to different channels here, but first ad pops up at the top, but then even here below, creating a hole using Whole Wizard in SolidWorks from Tabulum, who has the biggest SolidWorks channel out there. So that video has 111,000 views. I'm sure it's got some good content in it. Information here from Kevin Wood, SolidWorks Whole Wizard. Toby, Power Moves, Whole Wizard, non-planar faces. That is going to be a great video, I'm sure. And 6 minutes. You're going to learn a lot from that as well. So there's usually going to be some great references that you can find in no time at all to learn a tool like Whole Wizard. And this would go across a wide variety of different SolidWorks tools. Beginner tips, Whole Wizard as well. And even a video from SolidWorks themselves. Okay, so that's option number 2. Option 3, you can start to get really smart. And you can go to your AI tool of choice and ask the same thing. Hey Gemini, teach me about a Whole Wizard tool in SolidWorks. Same question, nothing fancy, and it's going to probably give you a slightly better answer than what you'll get from a Google search or potentially from some of the videos that might be maybe a little bit out of date. I'm not saying that the Whole Wizard has had any major updates in the last couple of years, but it's always best to try and get the most current information for any tool you're using. So you can see Gemini's coming up there with some information, 2 core tabs, okay, the type of the hole and the positions, goes through a series on how to create a hole, launching the tool, defining, setting the depth, switch to positions, place and constrain and confirm the feature. And then again, information, the most important part, why the hole wizard is essential. All right, so there's 3 ways that you can learn about any tool in SolidWorks. Now I'll show you a bit of a demo on what some of those elements from the hole wizard actually mean when you're creating a part, and some different examples of where it can be useful for you. And I'm just going to create a solid body, and I'm going to do it with a round cylinder so that I have a nice center point to select. Now the hole wizard tool is up here on the features tab. It's not going to come up, it's not going to show itself until you already have a solid feature or a solid body in your file to cut a hole into. Just like the same thing with a cut extrude. Can't cut extrude unless you have something there already. Click on the hole wizard. If you're quick, or once you're experienced with this, you might say, hey, I actually want to do a hole on this face. If you select this face first, and then you click the hole wizard, it knows where it's going to position or what plane you're going to position it on. All right, so that can save you some time. Let's just click off that for now. Click the tool, hole wizard, and it comes up with 2 tabs. Okay, just like the search and the AI tools told us, there's a type and there's a positions tab. And the position tab says select the face for the hole or slot position. You can also use this for slots. To create holes on multiple faces, you click 3D sketch. More advanced topic, let's start with the 2D. Type, generally you would pick this first. Now, if you have favorites, you could use your favorite selections here. If there's a hole that you're using regularly because of the certain type of work that you do, you can save it as a favorite. The hole type. So you can see here, if you hover over each of these, it's going to bring up with a little pop-up the name of the type of hole. So you get a visual that you can see straight away, but then you also get the hole types. Now, some of them look the same, like here, this is a hole, whereas this one is a straight tap, right? So you need to learn about the different types of holes and what they mean to understand the difference of the types here. I'm not going to teach you all the different hole types. That's something else you can look up yourself. But it does show you all the options. So you have 6 options at the top for holes, and then you have 3 at the bottom for slots. And then you have your selection as your standards type, which will retain the information from the last hole wizard that you've done. Now, I'm working in metric, so I have ANSI metric. But if you had a different set of standards that you're working, or in inches, you could choose that selection there. Now, when it's creating the hole, you pick the hole type. So let's say I want to do a counterball. You then select, depending on your selection of hole type, you're selecting the type of fastener that's going into it. All right, so it will know if you're using, let's say, a socket button head cap screw, and you're going to choose an M5 size, and you choose the fit. So whether you want it really close, normal, or a little bit loose, you can choose those options. And that's going to set the dimensions. You'll notice on here, there's no actual dimensions for you to say how big the hole needs to be. You can do that if you click on custom sizing. That's where the dimensions are hiding, and you can change them, but generally you just pick the fastener and the size and the fit, and it will work out the rest. The end condition is important. Just like you're doing a cut extrude, the end of your hole can go all the way through or a certain distance blind, or you can go up to a body or up to a surface or offset. Okay, like a lot of the general options that we would have with cut extrude tool. And then you have additional options at the bottom for head clearance, near side countersink, underhead countersink, far side countersink, and tolerance. I believe those options will change depending on the type of hole that you select. So you can see when I select a standard hole, I'm no longer choosing from screws as far as the type. Okay, I'm choosing what type of hole it is. Is it a dowel? Is it a drill? Is it for a helicoil? Is it for a screw clearance? A lot of times you might just be doing a through hole for a screw clearance. You choose the hole size, 5. So it's going to do a 5.5 mil hole. Standard clearance. That's normal. If I chose close, it's going to make it 5.3 millimeters. Right? So depending on your selection of the hole type, the other parameters, the other properties down in that tree, they're going to change. Right? And then the tolerance and precision. This is important for when you do the drawings of the file. So you create your part. Later, you might then want to create a drawing to communicate the manufacturing of that part. This information here is relevant for the drawing. So you can do a hole call out on the drawing, and that's going to reference this information. So whether it's a through hole, counterbore, you can choose the type of the tolerancing, whether it's basic, bilateral, symmetric, etc. And then you can choose the number of decimal points. All right, so let's try a hole now. So we're going to do the counterbore. So all that's left, I click on positions, we click on our face. All right, and then we can see as we drag the cursor on that face, we're getting a preview of what it's going to look like. Now we've done ours from the origin, so we have an origin there to select if we want to get it right in the center. Alternatively, and I'll show you afterwards, you can pick somewhere else and then you can add dimensions to the sketch, okay, to work out the position. So I'm going to click here. And if I wanted to add another hole, I'm just going to add another point. Or I can add lots of holes. Now your holes can overlap. It's just going to cause issues with the shape you cut out. But there's nothing stopping you doing that. If I want to remove some points, I can either right click and go select, or I can press the escape key. And then I can select those points to move them or delete them. Once I'm happy, I can just press the tick and it's going to create that hole for me. Right? So we look in the feature tree, we can see counterbore for M5 hex head bolt. It has 2 sketches. One sketch is the point for the location. The other sketch is all the geometry you need. It looks like a revolve cut, but the feature shows a hole wizard feature. You can manually change the sketches, but I really would recommend, if you want to do any changes, go in and edit the feature and change them in here. Okay. All right, so should we show a couple of other examples very quickly? So the next example, let's say we want to do a hole on this side, click the hole wizard. Now it's going to have the same features, the same information from your last hole wizard. So we can go through and use that again and just click position and drop a point. And now let me show if we want to add dimensions. I've just pressed escape. I can use my origin. I can make it vertical. I can also add a dimension. So all the things you can do with a normal sketch, you can use in this sketch to create your hole positions. You can also do something like a pattern. So here I can do a circular pattern. It's going to create 4 points. All right. Now I just have to get them fully defined. And I could do that with something like a circle. Grab that, put it on there. Okay, that's all fully defined. I've got 4 holes now. Press the tick. And those 4 are all controlled by this counterbore. Now, last thing I think we'll get into for this demonstration is, all right, that's fine for a flat face. What about if you want to do a hole on a curved face, something like this? Well, that's where you click hole wizard. Let's just change to a countersunk, click on positions. It's not a 2D plane, so we're going to click 3D sketch. And so now we're in 3D sketch mode. And you can see as I move my cursor on this face, it's showing me a preview. I'm going to click OK there. Now that position, I'm going to need to dimension it if I want to fully define it. So I might have to work with some existing geometry to try and get it to the right position. Going from the origin here is probably not the best solution. Maybe I can go from these 2 faces instead. Yes, I can put that one in. And then what else can we do? If I look at a front view or a side view, and make that a long line. All right. So a couple of construction lines for geometry in a 3D space. I've fully defined the sketch. Press OK. And now that hole is going straight through my object on a 3D plane. The hole wizard doesn't just cut geometry, it stores specification data, standard, type, size, fit. That data drives drawing callouts, bond length annotations, and smart fasteners downstream. If you manually cut a hole with extruded cut, you lose all of that. Part looks the same, but the model isn't the same. Choosing the right hole type and standard at creation time means your model communicates intent, not just shape. That's the difference between a model that works in isolation and one that works in a professional workflow. So how you can think about this in future: learn tools by mapping their structure. Input, output, options, design intent. For the hole wizard, the type, the standard, the specification, the placement, in that order, deliberately. The right hole type carries information, cut extrude doesn't. If you want to build this kind of systematic approach across SolidWorks, the fully defined community on Skool is where that work happens. Link in the description. Thanks. I'll see you in the next video.